Okay, so we discuss the antimicrobial susceptibility testing. So this topic will be discussing about the method here and how we're able to know if your organism is resistant or susceptible to your certain antibiotics. It's needed here for the treatment of the condition of the patient. Okay, so this because by doing your culture and sensitivity test, so the last part of that is your sensitivity test or the antimicrobial susceptibility testing, you're able to detect here which antibiotics the most effective because we'll be testing that one in vitro with your Petri dish. Okay, so basically antimicrobial susceptibility testing here, okay, will determine if your organism will be resistant or susceptible to your different antibiotics. Pag sinabing resistant, so that's mean to say your antibiotic will not be effective against that certain bacteria. If your organism here is susceptible, then okay, it's effective. Okay, so when speak about susceptibility, resistant, pag sinabing resistant, if you try to grow it in a culture media with your antibiotics, okay, your bacteria still grow. Okay, andun pa din sa bacteria natin, growing, so mean to say resistant. But if, for example, in the presence of your antibiotic, then the growth or the bacterial growth has been inhibited by your antibiotic, magkakaroon ng zone of inhibition, then we consider that antibiotic or that bacteria is susceptible to that antibiotics. Okay, we have here, when we're doing your antimicrobial susceptibility testing, we are standardizing all the factors. Okay, standardization here, number one, to optimize the bacterial growth condition. Hindi tayo pwede na anong gusto lang natin na temperature, anong incubation air, anong incubation duration, and all the other requirements. We need to standardize to make the entire procedure homogeneous and standardized throughout laboratory. The second one, to maintain antimicrobial activity. And lastly, to maintain here the reproducibility of your test results. Mean to say, if you test it in another laboratory, you still get the same result as yours because you are following a standardized procedure. Okay, what are we standardizing when we're doing here your antimicrobial susceptibility testing? So number one, we try to standardize our inoculum size. So again, hindi pwede na madami, sobrang dami na bakterya. Hindi pwedeng konti na bakterya ang gagamitin natin when we are plating it in our culture media and testing it with your several antibiotics. There's certain standardized inoculum size. Second one, growth medium. So our culture media should maintain also here other standardized factor like maintaining the proper pH, cation concentration, thymidine content, and many others. We'll be discussing each of that later on naman. Third one, we have also incubation atmosphere. So ano bang gas requirement niya. Then incubation temperatures, pag bacteria, we are using 35 degrees Celsius. Incubation duration up to 24 hours ba? 16 to 18 hours, 16 to 20 hours. Another one, we have your antimicrobial concentration. This is pertaining to your concentration of your antibiotics. Like ilang microgram per ml. Okay, like our tablet, di ba? It's milligram, ganon. But if you are using your antibiotic, okay, this na ginagamit when we are doing your susceptibility testing, that's microgram per ml. Okay, then we have here the conditions we try to have here a conflicting results between the result of your in vitro testing and your in vivo. Pag sinabing conflicting result, pag sinabing in vitro, you try to test your antibiotics or bacterial inoculum resistance against certain antibiotic here in the laboratory. That's in vitro. Pag in vivo, mean to say that's the actual taking of the patient with the medication. Kung minsan, tinest natin in the laboratory, okay, susceptible ito sa antibiotic na to, effective ito, pero nung ininom niya, okay, hindi siya naging effective. So, bakit nagkaganon? Okay, we have here some factors of that. Number one, antibiotic diffusion in your tissues and cells inside your body. So remember here that pag pumasok pag ininom natin yung antibiotic natin, hindi naman siya directly na mag-react sa ating bacteria. It try to go through different part of your body. It might be destroyed or it might be decrease ang kanyang reactivity or activity or its effect upon contact with the different secretions of our body. So, mga ganong factor. So another one, we have here serum binding protein. You have also here the drug interaction, interference. The status of the patient depends on the immune system. So most likely pag immunocompromised ng patient natin, so medyo mahirap ang treatment natin. Another one, multiple simultaneous illnesses. Currently, ang patient natin ay may madaming infection or madaming diseases. So it might be also the reason kung bakit hindi magiging effective inside the body of the patient. It might have some condition might be responsible for kung bakit siya hindi naging effective. Another one, we have the virulence and the pathogenicity of your microorganisms. And another one, site and your severity of the infection. So kung sobrang severe, sobrang dami ng infection, so medyo nahirapan ang ating antibiotics. We just normal na concentration lang na tinest mo dun sa ating inoculum or in your laboratory. Okay, then we have here the factors to consider when are we going to perform your antimicrobial susceptibility testing. Okay, so hindi lahat after you perform here after you have isolated your bacteria in your different culture media, hindi lahat or would eventually be you proceed with the antimicrobial susceptibility testing. Okay, so sometimes you need also to differentiate if that one is really the one causing the infection or is that a contaminant. Pag contaminant lang, we're just wasting our time, di ba? Kung contaminant lang yan or what you have isolated, for example, is just the normal microbial flora. So again, hindi pwedeng magbigay ng gamot ang ating physician wherein that is directed towards your normal microbial flora. Kasi pag binigyan na ng gamot, mapapatay niya ang normal microbial flora natin. Remember that your normal microbial flora, there are so many significance of that in our body. So therefore, for the actual treatment, the physician should treat only here the bacteria that is really the one causing the infection. Hindi yung contaminants or hindi yung ating normal microbial flora. So number one consideration here would be the body site where you try to collect the specimen. Example here, E. coli. E. coli, Escherichia coli is found normally in our colon. So normally, andun siya sa stool sample natin. So if you have your stool sample, tapos na-isolate mo ay Escherichia coli, then of course that one is not. Okay, so normal naman siya sa stool natin. So why should you treat that one? Why should you perform the antimicrobial susceptibility testing? Not unless you are testing for the water sample. Okay, your water source here of your drinking water. So, if that, for example, your water source has been contaminated with a stool sample, tapos naka-isolate ka ng Escherichia coli, mean to say the water system in your house or your household, in your neighborhood, has been contaminated by the fecal sample. So, therefore, okay, you test for that. Pero kasi pag ang stool mismo ang ating sample, or yun ang sinabit patient natin, then E. coli ang isolate mo, it's given naman may E. coli yan. Why treating for that? It's not the one causing the infection. Another one, your strep viridans, they are normal inhabitant of your oropharyngeal or oropharynx. So, your throat swab with a strep viridans, the presence of your strep viridans in your throat swab is normal. Another one, staph epidermidis, usually found in our skin. So like if your specimen is wound or even abscess, so normally andun sila. Not unless ang lahat ng ito ay na-isolate natin sa blood culture. Okay, remember that our blood is sterile for our bacteria. Dapat walang bacteria ang ating blood. So if, for example, you perform the blood culture and you try to isolate any other organisms, okay, pathogenic bacteria, then that would Signify here that you need to perform your antimicrobial susceptibility testing because that one is a true infection. Another one, we have the presence of other bacteria in your specimen and the quality of the specimen. So for example here, urine culture and sensitivity, you have isolated more than 2 organisms. So more than 2 organisms, it will signify na it's a contamination. With a bacterial count of 10 is to 5. So sobrang dami ng more than 2 population of your organism isolated from your urine when you're doing your culture. So that would signify that one is contamination, is a true infection. And therefore, you should not proceed with your antimicrobial susceptibility testing. Or, think about that one, you need to request a patient of another urine collection. Okay, another one, sputum specimen containing here few Klebsiella pneumoniae and other oropharyngeal bacteria is normal. Okay, not unless wala kang makitang other uropharyngeal or oropharyngeal na mga bacteria, and what you have identified is only present lang ay Klebsiella pneumoniae, so it's a true infection. Then you proceed with your antimicrobial susceptibility testing. But if you have this too, okay, then that's a contamination. It's not a true infection. Third one, we have here the host immune status. So basically, in the case of your immunocompromised, elderly patient, or even newborn. Okay, like for example, in the case of someone with staph infection. So, staphylococcal infection here could be treated by your penicillin. Okay, that's the standard. Okay, but however, the patient natin ay meron siyang allergic reaction with your penicillin. So, you might consider testing other antibiotic for that. So, since okay, penicillin resistant siya or allergic siya sa penicillin, of course, you will not be giving penicillin to that patient kasi allergic reaction siya doon, di ba? Because usually, we are treating staph infection with your penicillin. So, since meron siyang allergic reaction with that, then you try to consider other antibiotic. Erythromycin, you can test for that. Pero normally kasi, erythromycin is not being given to your staph infection. Kaso nga lang, we are considering na may mali sa immune system ni patient. It might be because of that problem with the immune system, it might be magiging iba ang result ng kanyang antimicrobial susceptibility testing. Like, baka maging effective sa kanyang erythromycin. But never ever go with your penicillin kasi given na yan na allergic reaction ang patient natin. We'll just be wasting our time and effort na mag-culture and sensitivity pa tayo with the penicillin as your antibiotic. Kasi hindi mo naman ibibigay yan sa patient. Kasi nga allergic reaction ng ating patient with your penicillin. Okay, we have here the principle of your antimicrobial testing. So, antimicrobial testing is just testing the effectivity of your different antibiotics against your isolated organisms. This would detect here if your organism is resistant or susceptible. Also, I would able us then to measure the antimicrobial organism interactions. So, we can perform here mga kill tests, mga kill time studies, or mga minimum bactericidal concentration to know here how much or what would be the effective dosage of your antibiotic that kill, that suppress, something like that. Okay, so we have here so the first step in windowing here with our antimicrobial susceptibility testing would be the standardization of your inoculum size. Okay, so from your plate where you try to inoculate your organism, you need to pick here approximately 4 to 5 na isolated na colony. So, for example, if you try to plate in your general isolation media or even in your selective media, your bacteria, then you have here your quadrant streaking. So, pag ito siya, we have here an overcrowded na colony in this part, in this one, this part. So, we need to pick itong mga isolated na colony or yung mga isa-isa na colony. Because most likely that one is the pure colony. Okay, so hindi ito yung contaminants or hindi siya yung combination ng other organisms. That's why approximately you need to select here 4 to 5 isolated colony from your pure culture. We consider this one as your pure culture. And after that one, so try to pick with your inoculating loop or your needle and then try to inoculate that one with our broth medium. You could have your thioglycolate or you could also have here your 0.85% sodium chloride or your NSS, normal saline solution. And after that one, you try to wait for the turbidity. And then try to match the turbidity of your inoculum with our standard inoculum. Our standard inoculum here is your 0.5 McFarland standard. Okay, so ito yung magiging comparison natin. Compare natin ang turbidity ng ating inoculum. So, i-wait natin siya until magkakaroon siya ng turbidity. We try to match the turbidity of your standard inoculum, which is your 0.5 na McFarland standard. Your 0.5 McFarland standard is made up of the following: is a barium sulfate. It's a combination of 9.95 ml of your 1% sulfuric acid and 0.5 ml of your barium chloride. So you try to combine it one, it will able to form here barium sulfate. Okay, so you need to compare this one with our McFarland standard either by visual comparison. Iko-compare mo lang sila dalawa. Ito ang McFarland standard, ito yung inoculum mo. For example, ito yung McFarland standard, ito yung inoculum mo. Iko-compare mo lang ang turbidity nilang dalawa. So for the comparison, pwede kang maglagay ng white na background na paper na lagyan mo ng mga ganyan, black na line for you then to really ascertain the turbidity of that. Okay, so here, pag sobrang thick ang turbidity ng inoculum mo compared to your McFarland standard, you need to dilute that one. So, until na magmamatch siya sa turbidity ni ating McFarland standard. You can dilute that one by addition of your much more NSS or more broth medium. Pag sobrang thin naman, you can add, kukuha ka ulit dito ng bacteria inoculum and wait until na mag-match dito siya ng kanyang turbidity with your McFarland standard. Okay, so if this one is your standard inoculum, it contains the standardized na bacterial count. So if you are doing here your broth dilution here will have, okay, bacterial inoculum size should be 5 times 10 to the 5th colony forming unit per ml. If you are doing your agar dilution, your standardized inoculum size should be 1 times 10 to the 4th. If you are doing here your Kirby-Bauer diffusion method, that should have your 1.5 times 10 to the 8th colony forming unit per ml. So again, you need to standardize that one. Ano mangyari, for example, pag hindi siya na-standardize sa inoculum natin? Like, sobrang dami ng bacteria mo. Pag sobrang dami ng bacteria, magiging resistant ang bacteria natin with your antibiotic later on pag tinest mo na siya. Pag sobrang konti naman ng bacteria, magiging susceptible. Pag sinabing susceptible, papatayin siya ni antibiotic natin. But these are false na result. Because again, you need to standardize by comparing with your McFarland standard. So you should not proceed with your antimicrobial susceptibility testing, not unless first you try to prepare your standardized inoculum using this procedure. Okay, we have also here the selection of your antibiotics. Okay, what are the antibiotics that should be tested against your inoculated na or isolated na organism or bacteria? Number one, you should have here your organism identification or group. So, kada group ng organism natin, there's a selected mga panel ng antibiotic natin in the laboratory. So, just refer to that. Another one, acquired resistance pattern. Okay, like, of course, here, if the patient, for example, would have developed already resistance against certain antibiotic kasi sobrang palagi niya ginagamit. So, first thing is, do not include that one in your antimicrobial susceptibility testing. How would you know here na resistant siya? Of course, you try to check for the history of the patient. Or you could also include much higher concentration of that antibiotic or other higher form of that antibiotic. Number 3, antimicrobial susceptibility testing method use. Ano bang gagawin mo? Broth dilution ba? Agar dilution ba? Or dish diffusion? Number 4, site of the infection. So like, if you are testing for the urinary tract infection, then select add your oflafloxacin, ciprofloxacin, your nitrofurantoin, ganun. And number 5, availability of your antibiotic in the formulary. Okay, so kung ano lang meron kayo, then of course that should be selected. And number 6 here, patient group. Okay, pag pediatric patient, dapat hindi mo bibigyan ng fluoroquinolones because it try to damage the cartilage development. And do not give also tetracycline kasi magiging metallic ang kanyang teeth. Okay, try to damage the teeth of the patient. Okay, the first, so we have here the conventional method of your antimicrobial susceptibility testing. So the first one, we have here your broth dilution. So broth dilution here, we are using broth in the form of your thioglycolate. Okay, basically, or even the NSS. Okay, so there are two methods for that. We have the macro and your micro. The macro is being carried using your test tubes. Okay, approximately that's 1 to 2 ml. Or you could also use here your micro dilution with the use of your micro titer well or trace. Approximately could accommodate that with a volume of 0.05 to 0.1 ml. Okay, so when you're doing here the dilution, you try to dilute your inoculum with your antibiotic here with in a two-fold dilution. Sinabing two-fold dilution, you try to dilute that one half from the first tube to the next, you need to reduce by half. How are you going to make here your two-fold dilution? So basically, like if you have already your standardized inoculum, okay, so you try to prepare here. So in my example, we have 1, 2, 3, 4, 5. 5 test tubes. Okay, then beginning on the tube, this is tube number 1, 2, 3, 4, 5. So tube number 2, 3, 4, 5, you add 1 ml of your diluent in the form of your NSS. Or you can also use your broth medium in the form of your thioglycolate. Okay, so, but not on the first one because the first one contains here the concentrated or the highest concentration of your antibiotic. Okay, like for example, if our antibiotic here would have the concentration of your 8 microgram per ml, so ito yung pinaka-highest concentration ng antibiotic natin. But we were going to dilute it one to give you a two-fold dilution. Okay, so first tube here, what you'll be adding here will only be your antibiotic plus your 1 ml of your inoculum. So, pwede itong 1 ml din ito ng 8 microgram and 1 ml ng inoculum natin. Okay, then after that one, so still have here 8 microgram per ml kasi wala tayong diluent na NSS na nilagay. Then after that one, you will be preparing 1:2 dilution because this is a two-fold dilution. Okay, so since meron ka ng 1 ml dito, okay, para makagawa tayo ng 1:2 dilution, 1:2 dilution is 1 part ng solute natin and 1 part ng diluent natin. Hindi ibig sabihin ng 1:2 dilution is 1 part, hindi ito, it should be 1 part ni solute, itong solute natin, 1 part ni solute, saka 1 part ni solvent natin or your diluent. Hindi na 1 part ni solute and 2 parts ni solvent. Because the 2 here sa baba, your denominator pertains to the total volume ng solution natin. Pag sinabing solution is your solvent plus your solute. So therefore, 1:2 is prepare here 1 part ni solute saka 1 part ni ni solvent. So since may naka-standby na tayo na 1 ml dito lahat, 1 ml dito, 1 ml, 1 ml, 1 ml ng ating diluent, all you need to do is just mix this one. Okay, and then transfer 1 ml to this one. That gives you 1:2 na dilution. Then, tube number 3 is prepared here by, again, making a 1:2 dilution. Since meron ka ng 1 ml ni diluent dito, so, imimix mo ito, then kukuha ka lang dito ng 1 ml, that gives you a 1:2 na dilution na rin. The same through with this one and that one. Since you are diluting your entire solution here 1/2, so your antibiotic concentration is also being reduced to half. So from the first one, since you don't have a diluent on this, so still 8 microgram per ml pa din siya. And the second tube that gives you 4 microgram per ml because you try to divide it by 2, divide by 2, divide by 2. Okay, that become here your dilution. Okay, so that's your twofold dilution. Okay, then after that one, okay, you try to incubate that one at their corresponding temperature and incubation requirement. So in the case, for example, of your Enterobacteriaceae and your Pseudomonas, okay, so we are using here broth medium in the form of your Miller-Hinton broth. Ay, wait lang ha. Your diluent here dapat, hindi pala NSS, dapat Miller-Hinton broth. Okay, so Miller-Hinton broth ang ginagamit natin as your diluent. Okay, so we have here again for Enterobacteriaceae and Pseudomonas aeruginosa. So our medium here is your broth in the form of your Miller-Hinton broth. So pag sabing broth here, so hindi siya nagsusolidify, di ba? Okay, and then try to incubate at 135 degrees Celsius here for 16 to 20 hours. For your Neisseria meningitidis, again, that one is also having the Miller-Hinton broth here, but only that you'll be adding blood, your 5% horse blood. To the 5, you can choose 5%. And then try to incubate at 35 degrees Celsius. Plus, you need to add carbon dioxide because this one is a capnophile. Your capnophile, di ba? They are needing 5 to 10% of carbon dioxide. So, you need to provide that one 5 to 7% na kanyang requirement. Incubate for 24 hours. So, since this one is your broth dilution, so our standardized inoculum is 5 times 10 to the 5 colony forming unit per ml. Okay, now we go to the reading and the interpretation. So when you're doing your setup na ganito, okay, you need also to include here your control, your quality control program. So you can have here your positive control. You call that one your growth control. This is your positive control. So mag-grow ito because what is being present or the content of that is only your broth medium, your Wheeler-Hinton broth plus your inoculum. So mag-grow siya. Your sterility control on the other hand is your negative control. That's your broth lang. NSS, I mean you could also have here your broth. Sorry, this should be Miller-Hinton broth lang dapat. Okay, Miller-Hinton broth lang dapat. Okay, so making that one as your negative control. So this is the first thing that you need to check. Okay, so dapat pag positive control, may growth. Pag negative control, walang growth dapat. So pag hindi ganun na magiging result, mean to say you need to repeat the entire setup. Okay, then try to identify, for the reporting, identify the minimum or minimal inhibitory concentration. Minimal inhibitory concentration here is the highest, the lowest concentration of your drug or your antibiotic that try to inhibit the growth. Inhibition here pertains to, anong inhibition? It try to suppress the growth of your bacteria, but it doesn't mean it try to kill. It only try to suppress or try to inhibit the growth. So this manifested here as the absence of the growth. Okay, so again, this is the lowest concentration of the drugs that try to inhibit the growth. Pag nag-incubate tayo, ang ino-observe natin na result dito ay pag may growth siya, magkakaroon ng turbidity, cloudiness. Pag walang growth, then magkakaroon, clear lang ang ating solution. How are we going to identify the MIC? Like for example in this one. So, tube number 1, so for example, may growth siya. Tube number 2, may growth. 3, 4, and 5, wala silang growth. So, pag sinabing MIC, again, this is the lowest concentration of the drugs that try to inhibit the growth. Mean to say, mamimili ka dito sa walang growth or clear na solution. So, since ito ang pinaka-lowest na concentration, so 0.5 microgram per ml, so that's considered here as our MIC, minimal inhibitory concentration. Another way of reporting, you could also translate that one with our cut-off. Okay, your breakpoint cutoff. Your breakpoint cutoff is equivalent to your susceptible, intermediate, na result with our interpretation. So for the breakpoint cutoff, you need to choose only here dalawang concentration ng antibiotic lang, the highest and the lowest. Like in the case for this one, so ito lang, saka ito ang pipiliin mo. Then you try to add your inoculum and try to incubate and observe for the growth. Ganito pa din ang kanilang incubation requirement and try to observe for the growth here. So for our interpretation, if ang dalawang tube, the highest and the lowest concentration, may growth, ang interpretation natin ay resistant. Okay? Pag susceptible, pag ang dalawang tube, the highest and the lowest concentration ay walang growth, so signifying na susceptible ang ating bacteria with your antibiotic. On the other hand, pag isa lang may growth, isa ay wala, so that's your intermediate. So ang breakpoint cutoff natin will be your susceptible na result and your intermediate na result. However, the problem with your breakpoint cutoff, hindi natin alam kung ano pinaka-exact na concentration ng antibiotic natin, kung saan talaga siya nag-i-inhibit ng growth or saan talaga siya ang effective because again, range ang ating result. Another disadvantage of your broth dilution here is that medyo ano siya, because pag isang set up, okay, so isang antibiotic lang to. Okay, so pag madami, kung gusto mo i-test ang different antibiotic, madami kang test tube na gagamitin. Okay, so that's disadvantages here of your, those are the disadvantage of your broth dilution.